Normal one.
Huh?
Normal one.
Yeah, normal one will have. Why are you blinking like this? For simple thing, you are blinking just like this is a very simple question. A simple question and answer. Because V1 should be greater than V2. Why? Because the velocity decreases. That's why we are telling us voltage down. If you understand this concept only, we can go to the next chapter. Everything is continuity. What is the next chapter? Moving charge. No, not moving charge. Another one. Current, electricity. Yeah, electromagnetic induction and alternating current. Chapter 6 and chapter 7 is very tough. You will not understand not even a single point from that. Very tough. You should be so you have to understand this point, this chapter thoroughly. Chapter 6 and 7 is very tough. That we are going to take tomorrow. Tomorrow 6 and 7. Okay. So now. So, for a given time, current is equal to rate of flow of charge in a given time. For 1 second, how the current flows? That is the current. So, the limit tends that if current is equal to limit delta t is equal to 0, delta q by delta t. That is, if delta t tends to 0, what will happen? Delta t is also 0, what will happen? Current is also 0. That means it tends to 0. It will not flow, current will not flow. Q is charge. Time. So the rate of flow of charge with respect to its time. Okay, so in the circuit trend, yesterday only I described conductor and insulator. What you have to define now? What is conductor? What is insulator?
Conductor current.
No, any one person.
Conductor will conduct the current. Insulator will not conduct the current.
Okay, so insulator will not conduct the current. What is example for conductor and what is example for insulator?
Insulator diamond.
Not diamond. Glass also you can take.
Diamond
Glass, something like that. So insulator. So rubber. No, just one example. Which straightforward example? Glass. For conductor, copper, iron, nickel, cobalt, etc. But normally we use in our commercial purpose. Commercial purpose, like in house house it. There are how many houses is there in India? In world, how many houses is there? In house, industry, everywhere they use copper only. Copper wire. So so we can take one simple example of copper itself. In there you can take glass as the insulator, glass as the example. Dominant. So the conductor, define conductor and define insulator. Example is copper and glass. Okay, did you define the term? What is conductor? Then what is insulator?
Insulator will not conduct the current.
What is example? You written at that point?
Insulator example glass, conductor example copper.
Yesterday, what chapter we covered? Yesterday? Hydrostatic and? Electrostatic, three chapters, no? How many chapters we cover? Two chapters? Two. Okay. Two?
Electric charge and field, electrostatic potential.
Okay. So did you revise it? Do you have any doubt in that?
No, sir. Yesterday chapter is fully clear, sir.
Fully clear, okay. First we go for Ohm's law. Ohm's law is going to be directly proportional to voltage difference is directly proportional to the current. So V is equal to Ri. That is V is equal to R. R is the resistance. That is I can remove this constant by R. Then R is equal to 2V by R because R equal to now R is equal to V by I. So two potential combination. Potential difference across the ends. Combination is clearly sum of potential difference across the two individual lamps, two potential.
So V equal to IR or
V equal to
IR then, sir.
V equal to IR. RI or IR.
Okay, sir.
Ella one R V is equal to 2 potential V plus V. So 2V. So V is equal to 2R. R is directly proportional to the length. R1 is equal to V by I by 2. So 2 if you go upstairs, so 2 into V by I, which is 2R. So R is inversely proportional to area, directly proportional to length. inversely proportional to area. So rho R equal to rho by 1 by A. That is no specific constant. Rho is equal to 1 by A. Rho is equal to 1 by A. So equal to rho R is inversely proportional to 1 by A. So R is equal to rho 1 by A. That is constant. Specific constant. So V is equal to IR, I is equal to rho by A, which is, so this R if I substitute, it will be rho by A. So now EL is equal to, now E is equal to, so V is equal to, no this one, okay, so up to this one, so this if you change this, what will happen? I is equal to V is equal to I rho A. Okay. So if you take this value, if you take inverse of this, what will happen? V is equal to I rho A. So if you take this value, V is equal to I by A into 1 by inverse. Yeah. So this rho V is equal to I rho A. So V is equal to I rho A. So 1 by V is equal to inverse of it, A by I 1 by rho. 1 by V is equal to A by I. 1 by rho is nothing but sigma. Sigma is nothing but conductivity, specific conductivity. So specific conductivity is equal to 1 by rho. What is rho now here? Specific
Conductivity.
Specific constant. Conductivity sigma is conductivity. 1 by rho is specific conductivity. Specific constant.
Rho is specific constant.
Specific constant.
Sigma is specific conductivity.
Specific
Constant.
constant. Specific conductivity. Specific conductivity. Conductivity. So what is rho is directly proportional by 1 by A. Rho equal to R equal to rho by 1 by A. What is rho here?
Constant.
Specific constant. Okay, I will explain once again. Should I explain once again? V is equal to IR. V is directly proportional to current. So V is equal to IR. So R is equal to 2. If the voltage is 2 combination means 2V by I, which is 2R. So R is directly proportional to length. R1 is equal to V1 divided by R by 2, which is 2V by R, 2 by I, which is 2R. Then R is equal to 1 by A. R is directly proportional to length, inversely proportional to the area. So if R is equal to rho by 1 by A, which is specific constant. So V is equal to IR equal to I is equal to R. R is now rho by A. So I is equal to R by V is equal to IR. What is R here?
Rho 1 by A.
Rho 1 by A. So rho by A. So I into A rho by A. So V is equal to I rho by A. 1 by V is equal to A by I into 1 by rho. So if I take 1 by rho is nothing but specific conductivity. 1 by rho can be specific conductivity. So A by 1 by V is equal to A by I specific conductivity. So this one is this also so this one is just constant. Magnitude of E and E, magnitude of this one is magnitude of E. No, always you don't do this. Yeah. What? What? Now drift velocity. Drift velocity. So the drift velocity is, what is current I told you? Current. Then I have a equation. I is equal to
A by D.
no, Q by T, not A by T. How A will come there? Q by T. Q is charge. Charge will flow with respect to time. So now drift velocity. So the electron that moves with an average velocity, the electron that moves with an average velocity electron that moves with an average velocity and that is accelerated due to potential difference. That is accelerated due to potential difference. That accelerated due to potential. No, I told you yesterday. I need like book like this. Do you have book like this? You have to standard file. Huh?
Yes, sir.
Yeah, something notebook like this. Then only it will be easy for to write.
Because sir,
Okay, fine. Okay. This note is this note only this. You started plus one question here, right? Now plus two. Huh? plus 2. No, I don't want to keep biology, physics, chemistry. For everything I want to give separately, because otherwise you will be confused. And that's why I told you, you have to keep separate this notebook separately for plus 1 and plus 2. So everybody keep separate notebook for separately.
Due to potential?
Yeah, separate. Yeah, that's why I told you, you have to keep all the notebooks separately. Separate physics, separate biology, separate chemistry. Okay? So where I left?
Due to potential difference.
Due to potential difference. So just read fully drift velocity. What I give?
Electron that moves with an average velocity that is accelerated due to potential.
That is accelerated due to potential difference. So now first, taken this everything.
Yes, sir.
Okay. This is very complicated. That's why I told you, no, this chapter. This not only this chapter. This is tomorrow chapter, no, chapter 6 and 7. That will be still more complicated. Very, very complicated. So, so the electron moving, okay? Electron is moving, okay? So electron, what I will give? Charge Q, which is negative charge. Okay, potential difference. So the potential difference is V. That means potential difference. Potential difference is this value, any length. If you take specific length if you take, the difference is potential, and accelerated. This is the potential which accelerates the electrons. So if the potential, if the potential is more, what will happen?
It moves fast.
It moves fast. If the potential is less, means what will happen?
Speed will decrease.
Speed will decrease. That's why that's why the people used to telling, when the brightness decreases, voltage drops. They will not tell current is drops. So now we understand the definition now. So everything is continuity. So everything is continuity. Based on this only they will ask the question in the thing. Sometimes they will ask the theory part, or they will ask the problem based like this. Okay. So just repeat what I told you. Repeat.
Electron that moves with an average velocity that is accelerated due to potential difference.
Potential difference. So it's called a drift velocity. So sigma is the conductivity. Conductivity is equal to n E square by m. What is n?
Net charge.
Number of charge, not net charge. Net charge. Number of charge is the electron. M is the mass, and torque is the mobility. Not mobility. Velocity. Drift velocity. Drift velocity. So mobility is equal to E into E torque. What is that torque? This one is drift velocity. This one is mass of the electrons. Then nu is the mobility. drift velocity. Okay?
Yes, sir.
The rho, what is the rho here? Specific
Constant.
rho,
Specific conductivity.
specific conductivity. What is sigma then?
Specific constant.
Sigma specific constant. Specific conductivity. What is how sigma and sigma is equal to?
1 by rho.
1 by rho. Specific, so rho is now specific
Conductivity.
specific conductivity. So the specific conductivity, when the temperature increases, specific conductivity also increases. In for copper. The copper is the one that we normally use. Okay, and your rho is the temperature is increases steeper. This is linear curve, somewhat linear curve. That means the curve is like something like linear. So rho bar in nickel chromium. Nickel chromium is not that much needed. Nobody will use it.
Nickel.
Nichrome, nichrome, nickel plus chromium. Okay, then rho versus T decreases, specific resistance decreases for semiconductors. This also we are going to see. What is the specific resistance decrease? What is specific resistance means?
Physical.
Physical meaning of specific resistance.
Specific resistance.
What is rho?
Specific conductivity.
What is sigma?
Specific constant.
Specific constant. Okay, so this specific conductivity increases with temperature. For here, so here it is increases with temperature. That means if temperature increase, specific conductivity will increase. But here it is decreases, which is semiconductor. What is example of a semiconductor? You know any idea? Semiconductor. Semiconductor is a one that be used in all the motherboards of computers. PC, laptop, personal computer, laptop, Apple, everywhere motherboard semiconductor only used. So now we are going to see how this increase and decrease is happening. Okay? Did you take this?
Semiconductor temperature increase.
Temperature increases. No, temperature. See, temperature increases. The decreases. Specific conductivity decreases. Okay? Here, specific conductive resistance increases. Temperature increases. Specific resistance increases. This is not linear. This is not needed. Normally they will not ask. Specific conductivity. Sigma is specific. Sigma is
1 by P when the specific constant.
Specific constant. Specific constant specific rho what is the given rho?
Rho is the specific constant.
Specific constant.
Specific conductivity.
Specific
Conductivity.
sigma.
Specific conductivity.
No.
Rho is specific constant.
Rho is the specific conductivity. Specific constant.
Rho specific constant.
So rho specific constant da. Rho specific constant da. Conductivity sonna. Okay. So this is a rho specific constant. Sigma on the specific conductivity. What?
Yes.
Total work done is equal to current into delta V by delta T. So delta V, do you know? I is current. Delta V is not velocity. Voltage. Work done is the difference in the voltage into T. T is the time. So if this is a given equation, so P is equal to delta V, delta omega by delta W, not omega, W by delta T. So P is equal to IV. This you know, P is equal to IV, V is equal to I by R. P is equal to IV. Okay, V is equal to IR is what is how you got V is equal to IR? P is equal to IR, how you got? Simple. Ohm's law, that's all. This is not okay, this is the standard equation. This one is Ohm's law. Now we substitute this V equal to here, I square. So V is equal to IR, I square by R. I square by R. So if I substitute this, this is sufficient. This is sufficient. Or you can take elaboration. So V is equal to I square, R is equal to V square by R. V square by R. Because you know, right? So if you substitute I is equal to V by R, you can substitute I V square by R. So again, if you substitute V is equal to I square by R is equal to I square by R. So this is this concept. So P is equal to I square R. Power is equal to current into resistance.
W work done, sir.
W is work done. V is voltage difference. dV, that's why I put delta V. Delta V is the voltage difference. Voltage difference means what? Voltage difference means what? Voltage.
Flow of charge.
Voltage difference means the 2 point. Okay? V1, V2 minus V1, delta V. That is difference in potential between here and here. Difference in potential between V2 minus V1 is equal to delta V. That is difference in potential. That is the potential here V1 and here the potential here is V2. That potential will be different. What is then how the acceleration will be there? What potential will do now? You understand my question now? What potential will do now?
Distance.
Potential is and you can take any distance. See from here V1 to V2. Here V1 you keep, V2 you keep there. Anywhere you can keep. It's a difference. What potential will do? Increases? No, increases V2 is not. See, that's why I am telling you. See, V1 here I am kept here, the board I am kept here. V1 to V2. Okay, some point I am kept here. Now I can keep V1 here. V2 you keep the chair. What chair is there? The chair is there. No, there you can keep it as V2. So that's a potential difference. Potential between 2 points. What potential will do now? That's my question. My question is different. Did you understand my question? You didn't understand my question. That's why you can't able to answer. What potential will do?
Moving on, please.
Passing the current, okay, but it's not a correct answer. Almost correct only, but it's not correct answer. What is potential will do? Just how I teach you. Huh? Okay, it increases the electron, or it increases the electrons, or it will accelerate the electrons. Acceleration of the electron. Acceleration of the electron. Acceleration of the, that is the main application of the potential. That's why I told you, no, this is a current is there, the light bulb is there. now you don't have any problem. Normal, now it's normal. But the brightness decreases means what you will tell? You will not say current decreases. You will say voltage problem. Voltage problem. Why? The voltage will not. The voltage which is accelerating the electron at this particular speed is now decreased. Decreased. So you will tell as a voltage problem. So delta V. Delta V is the change in the voltage. So I is equal to V. So P is equal to I square R. That's why I told you, no, this class is very tougher. Next class also will be tougher. Today, tomorrow, day after tomorrow, all of the classes will be very tougher. If you cross the 3 classes, then another circle it's easy, somewhat easy. So if it is connected means series is connected means be like this, R1 R2 it connected like this. If it is parallel means parallel, it will be connected like this, because you will get mirror. See what is if I pass mirror to here this point to this point, what will I get?
Get the same image.
Same image. This will get same image. So that means it's parallel. So if I get a pass mirror like this, you will get same thing. But if I pass mirror like this in this which is this direction, this one horizontal versus vertical. If I pass like this, so R1 will be same as R2. That's all. So both are same only. Series and vertical, series and parallel are same. Only thing in which direction. So now if we see that, so this is the parallel connection, this is the series connection. Better.